Hello and welcome to this video on the TECH15 output in Mplus for mixture models. My name is Geiser. On this channel I present weekly statistics tutorials, usually related to multivariate statistical methods such as structural equation models and latent class and other mixture models, and often involving the Mplus software. If this is something that interests you, then please subscribe to this channel, and also don't forget to hit the like button and to check out the description for additional resources. In this video, I want to discuss a specific output option for complex mixture models that is available in Mplus, and that's the so-called TECH15 output. In my opinion, this is a very useful option when you specify a complex mixture model, such as, for example, a latent transition analysis or a multi-group analysis or something like that. And so I want to show you how you get useful information from that output. In this example here, I'm dealing with a multi-group latent transition analysis with 2 time points. I have a grouping variable that is here sex with 2 groups, and I have 2 latent class variables C1 and C2 that represent latent classes at those 2 separate time points. And so by using the known class option in Mplus, I can specify a multi-group latent transition model in which I can allow, for example, the latent transition probabilities to be different across gender groups. And so the TECH15 output, as we will see in this video here, allows me to then obtain the information of group-specific transition probabilities and other group-specific parameters in a well-organized way, so that it's easy for me to find the information that I would like to see. So this entire syntax file here specifies a multi-group transition analysis where the transition probabilities can vary across gender groups, and also the class sizes can vary across gender groups. And so in order to find those results that I would be interested in, I added at the very bottom this output TECH15 option so that I can look at all the relevant conditional response probabilities conditional on gender groups. So let's take a look at that portion of the output file for this multi-group analysis that has these probabilities. So I'm going to go to the output, and so here's my technical 15 output below all of the other output that you get in Mplus for such a multi-group latent transition model. And so I find this to be more useful than a lot of the other outputs. Some of this information you can also find in the Mplus standard output, but I don't find it as well organized as it is in this TECH15 output. And that's why I decided to make a video on that, because a lot of people are very confused when they run a multi-group mixture model and they only look at the standard Mplus output and they don't find what they want to see. And so a lot of people don't know about this TECH15 output. It's a relatively new feature in the Mplus software. And so in this output you get a listing of a whole bunch of unconditional and conditional probabilities that may be the result of your mixture analysis. And so here, first of all, we get the unconditional probabilities for the 2 gender groups. So gender here is my exogenous variable, so to say, that I'm using as the grouping variable, or we could say as a predictor variable, so to say, where I'm looking at whether the class sizes differ across gender, and also I can look at whether transition probabilities might differ across gender groups. And so here, first of all, I'm getting my unconditional probabilities for the 2 gender groups. So we can see that in the first gender group, which here was female, we have 47.6%. In the second gender group, we have 52.4%. So that was males and females. And so this simply gives a reflection of the observed proportions in that sample. And then next are conditional probabilities for the class sizes. So class size conditional on sex. And so here we can see that at time 1, which is represented by the C1 latent class variable, the size of that class, or the probability of belonging to that class, given that gender was female was 0.154, meaning 15.4% of females were estimated to belong to class 1 at time 1. The second class at time 1 then had a size, obviously, because there were only two classes, the size was then 84.6%. Those two probabilities have to add up to 1.0 because all females have to belong to either class 1 or class 2. There are no other classes here. So you can see that class 2 was much larger in group female than was class 1 at time 1. And then next we get the same probabilities for males. So for males at time 1, the probability of belonging to class 1 was 36.8%, so a little higher than the corresponding probability for females. And the probability of belonging to class 2 for males at time 1 was only 63.2%. So there's a gender difference here, potentially in terms of the class sizes at time 1 that we can infer from these conditional class probabilities. Next are transition probabilities conditional on sex as well, or in other words, we get the transition probabilities from the time 1 to the time 2 class variables estimated separately for each gender. There might also be gender differences in the transitions, and you can see that for females the probability of staying in class 1 over time, so where the C2 class variable takes on the value of 1 and the C1 class variable also takes on the value of 1, meaning they're staying in the same class in this case because we have measurement equivalence here across time, and so the C1 and C2 classes are the exact same. And so the probability of staying in class 1 for females, so given C sex equals 1, was 89.6%. So there was a high stability of class 1 in group female. The corresponding probability for C sex equals 2, so for males, was 0.999, so even higher. So there was an even greater stability for males for the same class. For class 2, we had lower stability, so this is the probability of staying in class 2 over time for females, and it was only 63.4%, so pretty much or a good amount lower than the stability that we saw for class 1. So the reason here is that class 1, so this was test data, and so class 1 represented a class of high performers, and so people who were already high performing at time 1, they tended to stay in that class, whereas class 2 was a lower performance class, and so there was a lot of improvement over time. As we can see here, there was a lot of movement from the time 2 lower performing class at time 1 to the higher performing class 1 at time 2, so relatively high transition probability in both groups, 0.366 for females and 0.376 for males. So this output here allows you to look at the transition probabilities separately for each group so that you can compare them between groups. Furthermore, we also get the so-called marginal probabilities for the latent class variables, so we get the estimated sizes overall, so to say not conditional on group membership. So the sizes overall across males and females of the two classes at time 1 were 0.266 for class 1 and 0.734 for class 2. And then you can see the class sizes changed pretty dramatically. At time 2, class 1 was the larger class then with 53%, and class 2 was then the slightly smaller class with 46.9%, and that reflects again the fact that there were quite a few transitions here from the lower performing class to the higher performing class in both gender groups, and so therefore the class size of the higher performing class over time increased because there was an influx of participants from the lower performing class into this class, and so the lower performing class became smaller, the higher performing class became larger across time. So I hope you were able to see that this TECH15 output provides very useful and very well organized output of conditional probabilities for latent classes that may be of interest when you have a complex latent class model, such as a multi-group latent transition model, or maybe a mover-stayer model, or some other kind of complex mixture model where you have multiple latent classes or latent classes and known classes. In that situation, this output allows you to stay focused on what you want to know, because a lot of the other output in Mplus can be a little bit overwhelming, and so I recommend looking at this TECH15 output when you have a complex mixture model like this one here. If you're more interested in mixture models, please check out the description where I list additional workshops that I provide on latent class analysis, latent profile analysis, and latent transition analysis. Also, leave a comment in the comment section if you have ideas for additional videos or would like to make some sort of other comment. And don't forget to subscribe to this channel and to hit the like button, and I'll see you next week.